Hello everyone. In this lecture, we will go over time series and forecasting very briefly. So time series and forecasting is actually a major topic in econometrics and statistics. It is useful when you have data recorded over time. Then for that type of data, the tools that you can use is slightly different from what you will learn in regression. So that's the reason we want to talk about time series very briefly in our class. Now, as I mentioned, time series is just data collected over time. It could be weekly data, monthly, or quarterly data. And in business, as you can imagine, there are a lot of times that you will collect data over time. For example, sales data, right? You're going to collect sales data probably every quarter or every month. And when you record such data, is time series. Or more frequently, stock price. It's recorded every day. So in that sense, you have time series data for each company's stock recorded every day over, how many years the stock is in place. So apparently, it is quite frequently that people will use time series data and they need to analyze time series data to do forecasting or another analysis. Another example is the case study some of you worked on before, and I also mentioned in class. We have the hospital inventory issue where the heart valves is overstocked at hospital by salespeople. And actually there, some people suggested that they should analyze data to determine what would be the optimal level of inventory. For that suggestion, if you think about it, if you want to analyze the optimal stock or inventory level, then most likely you will be looking at variables that would affect the stock. And also you would also consider time series data because you're gonna look at sales in the past, and that's time series data. Now, for time series data, what we observe is just the data recorded over time, but actually that series can reflect several components, and all of these components are mixed together, eventually form into the time series we observe. So we'll have 4 of them. The first one is secular trend. This is the smooth long-term direction of a time series. That is, when we look at sales data, first thing we would want to see is if the sales is increasing steadily. When we say that, we are actually looking at the secular trend. That is, we are looking at the overall direction of the time series. And the second component is called cyclical variation. Now, whatever time series data you're looking at, most likely, even though you can see an upward trend in general, there's still deviation from that general trend, which is reasonable and expected. And one of those components is the cyclical variation. This is the rise and fall of a time series over periods longer than 1 year. That is, a lot of sales data or a lot of time series data will be affected by the macroeconomic condition, right? We all know that there's this business cycle. The economy is going from recession to recovery, and then to the peak, which is boom. The economy is going in boom condition, and then going through this cycle again and again. Then our time series data can be affected by the business cycle of the economy that we would observe, or actually our time series data will contain cyclical variation. Of course, sometimes you won't be able to see this very clearly, but using some techniques that is available in time series analysis, we will be able to single out this cyclical variation. The next component is seasonal variation. And is the pattern of change in the time series within the year, which tends to repeat every year. Again, sales data. Think about it. Sales data for retailers like Target, Best Buy, Walmart, they do have seasonal variation because over the whole year, the sales will vary and the pattern will be the same year after year. In particular, the sales will be high in the fourth quarter because of the holiday, right? During holiday season, everybody is buying gifts, preparing for the holiday, buying a lot of things. So sales will definitely be higher in that season or in that quarter in comparison to the second quarter or the third quarter. And there are other seasonal variation for sales data. For example, if it's related to schools, then you observe seasonal variation throughout the year that is in accordance with school's demand, right? Usually before the semester begins, sales of school supply increases because people rush to buy school supplies, and the sales will be lower in other seasons when school is in session already. So that's the seasonal variation. And the difference between cyclical variation and seasonal variation is that the first one, cyclical, is the variation rise and fall longer than 1 year. Okay, so this is over years. And the seasonal variation is the rise and fall within a year. That is, this is changing over seasons. The last component is called irregular variation, which is residuals and exogenous shocks. So the irregular variation is something that doesn't present a pattern. There's no pattern. You can't say, oh, season 1 is lower, season 4 is higher, or you won't be able to tell, well, during economic recession it's lower or whatsoever. It's regular. It's random in a sense. And sometimes if there's exogenous shocks, you will see time series data being different or deviate from its traditional pattern. So that's the last component. And what we're gonna do is to examine these 4 components very briefly. I say that again is because we don't have much time to introduce a lot of things, but my goal in this chapter is for you to kind of have a general idea of time series and the 4 components. So starting from the first one, secular trend. And as I mentioned, the secular trend is the long-term direction, right? So to get the secular trend is actually something you just learned in chapter 23, simple linear regression. If you want to see how time series data is trending over years, what you're gonna do is to fit a straight line like this one, okay, to capture the trend. And that straight line is actually a simple linear regression of sales on time. So let's take a look at this example. It's the number of employees at Home Depot from 1993 to 2012. Okay, it's time series data. It's recorded over 20 years. If you want to know the secular trend, that is, if you want to know whether the number of people, number of employees is increasing overall, you first plug the original data, which is the blue dot, all right? And then you're gonna run the simple linear regression, and the dependent variable will be y, which is the dependent variable, will be the number of employees, okay? And for that simple linear regression, the x, which is the independent variable, will be time, and here the time will be year. Okay, that's the simple linear regression you're gonna run, and then you will get this secular trend. Of course, when I say the x variable is time or year, you wouldn't use 1993, 1994. Instead, you're gonna use 1 to denote 1993 and 2 to denote 1994. First year, second year, third year. Then you run the regression, you would get the straight line. That's the secular trend, okay? And that's usually the first thing people examine, that is, do I have an upward sloping? Do I see increase in the number of employees? Do I see my business expanding? Do I see my sales is increasing over time? Now the second one, cyclical variation, usually refer to the rise and fall together with the economic or business cycle. Okay, that is, we have recession, sometimes we call recession, and then recovery, and then prosperity. Okay, so we see rise and run of the sales data in this one. So this example shows the annual unit sales of batteries by national battery retailers from 1991 to 2010. And apparently this example is made up by the authors. There's no such company, and typically, I mean, time series data will not show such apparent pattern of cyclical variation. Most of the time, you have to tease out other components to verify the cyclical variation. But for illustration purpose, as you can see, for this data, apparently the author made up things that you would see the pattern going up and down, repeating itself, and the pattern is quite neat, just to show you there is such variation over years. So notice this pattern is going through over the 20 years. That's the second component. And the third component, seasonal variation. Here's the example about quarterly sales of Hatcher Sporting G Inc., a Chicago area sporting goods company specializes in selling baseball and softball equipment to high schools, colleges, and youth leagues. Okay, in this example, apparently we would expect seasonal variation because they sell equipment to schools, and schools run in academic year, right? School starts around August. So apparently before that, which will be second quarter, right, we would expect the sales for this company to be higher because schools are purchasing equipment. And then in the third quarter and the fourth quarter, schools are already in session for that whole academic year. You don't expect high demand, and therefore you don't expect high sales for this company. I'm almost sure that this data is made up by the authors too. It could be true. The reason is the author is trying to show us the seasonal variation, and the pattern is very neat. And again, usually we may not be able to observe such neat pattern. Nevertheless, it's enough for us to discuss what's going on. So they recorded the quarter data for 3 years, and they have the sales. And when they plot the sales data, the green line, as you can see, is going up and down in a pattern that is repeating itself over years. This is quarter one. Quarter two is the higher, and quarter three is the lowest one of the year. Quarter four is slightly higher. And again, quarter one, quarter two is the highest one, quarter three is the lowest one, and quarter four goes up. So you can see this pattern repeating itself again and again over years. That's the seasonal variation. All right, now let me illustrate time series analysis using Sears revenue data. And this is actually related to the data analysis project that I asked you to do as almost like the last assignment. Okay. So you're gonna use the sales data of the company assigned to you to finish that project, and I'm gonna use Sears for my illustration, and I'm gonna mention what is required from your part for that project when we go through the analysis. Okay. So apparently Sears revenue data is a time series data because it's recording quarter revenue of Sears over the years from 1995 to 2030. So in time series analysis, apparently the first step is to plot the data, to look at the pattern, look at the trend, and to do some analysis. And therefore, the first thing I require to do is, of course, to plot your seasonal data, okay, whatever company you're working on, plot the data, and this is what I have for Sears, right? There are several things we can see immediately, okay? We do, number one, want to see the secular trend, that is the overall trend of Sears sales. We don't see a very clear pattern of going up all throughout the years, but we do see that at the beginning of the session, in the early years and in the later years, we actually observe downward sloping trend. And the second thing we observe is that there's definitely seasonality of Sears sale data, because the pattern is repeating itself every year, going up and down, right? And even, I mean, without further exploration, we can basically tell the highest season will be season 4, then going down and up like that. So sometimes we actually would like to get rid of the seasonality if our focus is not on the seasonality. So next, I want to introduce a technique to get rid of this up and down over years, over the same year, and then just allow us to explore the overall trend. And this is called the moving average method. So moving average method is often very useful just to smooth time series to see its trend. Recall that time series has 4 components, and the seasonality fluctuation will kind of mess up the data. And also this irregular, the last component, irregular component, will also sometimes give us false interpretation. So we want to smooth out the time series just to see its trend. We don't want little bit irregular component to bother us in a sense. Then we need moving average method. Okay. We also, interestingly, we also use moving average method to measure seasonal fluctuation. This is because after you get rid of the seasonality, then you compare with the original data, you will be able to capture the seasonality. In particular, if the seasonal variation is not apparent. Not for the Sears though. For the Sears data, it's very clear that we have this up and down pattern. But for other time series data, if you suspect the seasonality, but it's not very apparent, you could consider using moving average method to capture or measure the seasonality. Okay, so here's the moving method, and here's how you construct the moving average time series. What I have here is the sales of a company over years from 1988 to 2013. Okay, and the original green line apparently didn't represent the sales over years, and this is definitely an example made up by the author, because you see this almost exact pattern of the time series data, right, repeating itself over years. Probably every, let's see, 10 years the data will repeat itself up and down, right? And say we want to calculate a 7-year, right here, 7-year moving average. Then what we're gonna do is, let's look at here, the table. What you do is you add the first 7 observations, okay, add them up, get the total, which turns to be 22 in our example, then divide 22 by 7 to get 3.143. And that will be the first observation for your 7-year moving average line. And to get the second observation, what you do is you add the second number all the way to the 8th number. So you add another 7 observations, but starting from the second observation in your time series. add those numbers up, we will get 23, and we use 23 divided by 7, we will get 3.286. That will be the second observation in your 7-year moving average. Okay, so what I suggest is, if you want to smooth out your time series using moving average, first you need to determine the number of periods you want to average. For our example here, apparently the situation is we're going to average over 7 years. Then you add every 7 years of sales data, divide the total by 7 to get observation. And you continue from the first observation until the very last one to get your moving average time series, moving average series data, the new series, and then compose it. Okay. And now in terms of choosing the right years to average, or in terms of choosing the right periods to average, it depends on the situation. You need to look at your particular case to determine what is appropriate. For this one, since we notice that the pattern is repeating itself every 10 years also, I said 10 years, probably 7 years, I would think. So you want to average out over 7 observations. Now, for our Sears revenue data, actually, if you want to smooth out, and this is also required for your data analysis project, that is, after you first plot the data, you need to smooth out the data using moving average method. Then you're going to pick the number of periods you want to smooth out. Now, since we'll notice there's seasonality in the data, apparently the best number of periods to average will be 4, because you want to average out the seasonality. And the data, the time series data repeats itself, the pattern repeats itself every 4 quarters. So you're gonna calculate the 4-period moving average, as I shown here. The red line will be the 4-period moving average. Okay, and the blue line is the original data. And you can do that in Excel using this command. So let me switch to Excel and show you how I can construct this 4-period moving average. Okay, it will take a few seconds because I'm gonna switch my window. All right, so hopefully by now you can see my Excel with Sears data. What you would see is the first column is the date, the second column is revenue data. I also added a few other columns. You can ignore these columns as of right now because they are relevant for the next chapter, multiple linear regression. Our focus in this chapter, time series, will be on the revenue data only. So first of all, let me plot my data. I'm gonna do Excel, I'm gonna do insert. I want to insert a line. And there we go. Okay. So I highlight my revenue data, go to insert line, and I've got this one. Okay, that's my time series plot of the original data. Okay, and of course, when you produce your plot, it's up to you. I didn't change the x-axis notation here. You can, if you want, you might want to change it to reflect the time so that you can tell when something happens. For example, the Sears data, apparently there's a big break around that period. Okay, you might want to add the years down here. But if that's very consuming, if you don't know how to do it, then don't worry about it. So how do I add this 4-period moving average? I would like to put my cursor on the plot, okay, somewhere, and right-click on it. Then in the pop-up window, there's an option that add trend line. Okay, click on it. You will have this window open. All right, And you will notice that this window is very similar to the one I showed in PowerPoint. Okay, as of right now, the default is a linear trend will be added. This is something we're gonna need later on, but as of right now, we want the moving average. So I click on the last option, moving average. I also want to change the period to 4 because I believe the seasonal pattern is repeating itself every 4 quarters. So I change it to 4. And there, I'm gonna obtain my 4-period moving average. Once you click on OK, you will get that plot. Okay, and the black one is my 4-period moving average. Of course, you can change the color. Well, before you click on OK to close it, you can also change the line color. I can change it to red to make it more apparent. I can also change the line style to make it thicker, so it's clear to me now. So you can do a few cosmetic changes to make the graph fancier, but it's up to you. So what I'm looking for is the basic analysis. That is, you have the original plot of the time series. You also have the appropriate number of moving average plot. Okay, whether it's 4 or 6 or 10, you make your own decision, but it has to be reasonable. So let me go back to our PowerPoint.